I'm live again, by the way.
So if I die in a trench, there's no point in studying, right?
There is point of studying. I'm live again. I'm a diva. I'm a diva.
Pakistan number.
I'm about to leave the school, Sam, because I need to study.
I apologize. I actually won't give you a due.
Join my live then. Talk to me on my live. I'm a diva. I'm a diva. Okay, lock in, Sophia. Lock in. What music? I'm going to be watching revision videos as well. I'm a diva. I'm a diva.
Skin is the first barrier to them entering, and if they do enter your nose and trachea, they can be trapped by mucus.
Shut the fuck up, Sam. I'm about to mute you from my.
Will destroy them too. If they still manage to enter the bloodstream, though,
I'm gonna mute you from my chat.
One type of these are called lymphocytes. They produce antitoxins to neutralize poisons pathogens produce, and also they make antibodies which stick to the antigen on a pathogen.
Exactly.
Being able to infect cells, and it makes them
exactly.
Phagocytes are then able to ingest them and destroy them. An antigen on a pathogen will have a specific shape, so that means only an antibody that fits it will neutralize it. If pathogens are unknown to the immune system, lymphocytes will start making all different shapes until one fits. Miraculously, your immune system will then store a copy of this antibody next to a copy of the antigen, so it's ready to stop it from causing an infection next time you're exposed to it.
Imagine failing all your exams in the Big 25. Exactly.
Usually a virus that exposes your immune system to the pathogen so it can produce the antibody without infecting you. For example, the flu vaccine, you're injected with
You will, because you're not studying.
So the DNA has been damaged and so it can't do the job. Incidentally, the COVID jab, however, was
no, 30% is not fine.
You're injected with the DNA, technically.
I'm going bold.
Needed to trick your cells into synthesizing part of the virus, including the antigen. It was the first.
I don't understand Irish grades.
mRNA technology. Antibiotics kill bacteria. They don't kill viruses. Penicillin was the first one. There are good bacteria in our bodies, so antibiotics are designed to be as specific as possible.
Penicillin.
Body cells either. Problem is, as bacteria
30% shit. 30% won't even make you pass in the UK.
Used to be extracted from plants and other organisms. For example, aspirin comes from willow trees, penicillin from a mold. Now, synthesizing drugs is one of the biggest industries on the planet. They have to be trialed to see how effective they are and to check for side effects. First, we do lab trials on cell tissue, then trials on animals. Next, human trials. We give the drug to a group of people, but we also give a placebo to a control group without telling them. Say a pill is just sugar, not the actual drug. This is what we call a blind trial, because the test subjects don't know what they're taking. A double-blind trial is when even those analysing the results from the test aren't aware of which group is which, and that's to eliminate any bias. Just for triple, this is a crazy one, monoclonal antibodies. They're made from clones of a cell, which is able to produce a specific antibody to combat disease. This is achieved by combining lymphocytes from mice to tumour cells. This makes a hybridoma cell. This is then cloned to produce a lot of antibodies ready to treat a patient. These monoclonal antibodies can also be used for medical diagnosis, pathogen detection in a lab, or even just identifying molecules in tissue by binding them to a dye so they glow when grouped together. Because they'll be
Sam, text and chat, please. I feel really lonely.
to these is that side effects are turning out to be worse than scientists expected. Photosynthesis happens in chlorophyll and chloroplasts in plant cells to provide food. Here's the word and balanced chemical equation for it. As energy is needed in the form of light to make this reaction happen, this is an endothermic reaction. The glucose made from photosynthesis is used for respiration or is turned into starch.
Most of it I see is red.
Cellulose is used to produce cell walls, and amino acids are used for synthesizing proteins. The rate of photosynthesis is increased with
Most that I see is red.
Denaturing occurs, increasing light intensity or increasing CO2
Yeah, but it's red.
One of these can be
Irish 10%. Maths 33. French 48.
It doesn't matter how much you increase the other two, it won't get any faster. The graph might look like this. Before the graph plateaus, levels out, the variable on the x-axis has to be the limiting factor. After, it isn't.
I don't watch
One
football.
of the other two instead. If you have two lines, for example, different temperatures, then temperature must be a limiting factor. Here's the practical on this. We can measure the rate of photosynthesis by submerging pondweed in an inverted measuring cylinder. We measure the volume of oxygen made over time. We can instead count the bubbles, but it's less.
It's under
The
50.
independent variable could be the light intensity.
But you won't pass in the UK with under 50.
From the light source, for example, a lamp. However, light intensity follows an inverse square
Voulez-vous
relationship.
que je avec moi ce soir?
Distance, the light intensity quarters. 3 times further, 1/9 of the intensity. Every cell, our red blood cells, has mitochondria, which is where respiration takes place to provide energy for every organism, for other chemical reactions to take place, for movement and warmth. Aerobic respiration means with oxygen. Here's the word and balanced chemical equation. As you can see, it's just the opposite of photosynthesis. During exercise, your breathing rate and heart rate increase to increase the rate of oxygen delivered to cells for respiration. Anaerobic respiration occurs when there's a lack of oxygen. Glucose is instead converted straight into lactic acid, which releases less energy. This is what you feel when your muscles ache during intense exercise.
Yeah, study, Sam. I'm studying.
So there is an oxygen debt built up.
I'm
Oxygen
multitasking.
is needed afterward to break it down in the liver, where it's turned back into glucose. Hence why your breathing rate and heart rate take some time to return to normal after exercise. Plants
I'm
and cells
a
respire
diva. I'm
anaerobically,
a
slightly
diva.
different. Instead, glucose is turned into ethanol and carbon dioxide.
No, I'm doing my textiles. I'm doing my art.
The CO2 bubbles made
Which is due tomorrow.
to rise. This can also be called fermentation. It's also used to make alcoholic drinks as ethanol is produced. Grouping all of these together, metabolism is defined as the sum of all reactions in a cell or organism. It can
I'm a
include
diva.
respiration,
I'm
conversion of
a
glucose,
diva.
starch, glycogen, and cellulose. Glucose can also be built into cellulose, which is used to make cell walls. Glucose and nitrates are used to make amino acids for protein synthesis. Fatty acids and glycerol are built up into lipids, and also the breakdown.
It's not a podcast, it's a science video.
Into urea. More about that in paper 2. So I hope you found that helpful. Leave a like if you did. Any questions or comments below. And hey, after you've done the exam, come back here and tell us all how you found it. We'd love to know.
An hour and a half. Yeah. No.
Hi, and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe how certain diseases can be treated using antibiotics. You should then be able to describe what's meant by antibiotic resistance.
I do it all the time and I pass really good
In the
grades.
previous video, we saw that many diseases are caused by bacteria.
I'm not a nerd, I'm just trying to figure out my life.
In many cases, bacterial diseases are extremely unpleasant and they can be fatal. Until the 1940s, many people died from bacterial diseases. However, around that time, scientists discovered the first antibiotic, which is called penicillin. These days, the use of antibiotics means that most bacterial diseases are treatable. Antibiotics such as penicillin kill infected bacteria inside the human body without harming body cells. Now, there is a problem with antibiotics. This is called antibiotic resistance, and we're going to look at that now. Several years ago, doctors discovered that certain antibiotics were no longer effective against certain bacteria. That's because antibiotics have been overused. That meant that the bacteria had evolved, so they're no longer killed by the antibiotic. Scientists call this antibiotic resistance. Now, antibiotic resistance is a serious problem. It's possible that in the future, bacterial diseases will become very difficult to treat. We'll be looking at antibiotic resistance in more detail in a later video.
What?
There are a couple of other parts of antibiotics that you need to know.
I'm looking at the.
They always use specific antibiotics to treat specific bacteria. Antibiotics cannot kill viruses. That's why doctors
A diva.
conditions that may be caused by a virus. For example, certain types of sore throat. One type of drug that doctors will prescribe is painkillers. Painkillers treat the symptoms of the disease by relieving pain. However, medicines such as painkillers do not kill pathogens. In other words, they do not treat the disease itself. Now, as we said,
No, it's summer in the UK, meaning we get more flies.
viruses live and reproduce inside human cells.
Stinky bed. At least my bed's made. Yours probably isn't. You have a Christmas tree in your room. You're probably a bunch of shit all over the floor. You can shut the fuck up, Pom Tam.
Okay, so hopefully now you should be able to describe how certain diseases can be treated using antibiotics. You should then be able to describe what's meant by antibiotic resistance.
I'm a diva. I'm a diva. This is not rage, babe. This is me telling you to lock in.
Hi, and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe how new medicines are discovered and then tested. In the last video, we looked at medicines such as...
Are you revising, Pom Tam?
New medicines are being developed all the time, and all of them have to be extensively tested. So first, we're going to look at where new medicines come from. In the past, medicine was extracted from plants. This shows the plant foxglove, which was used to extract the heart drug.
It doesn't take that long to set up. Just get a piece of paper, pen, load up on the screen, then you're done.
Drugs were also extracted from microorganisms. For example, the
I'm a diva. I'm a diva.
penicillium. These days, most new drugs are synthesized by chemists working for pharmaceutical companies, but the start
Yeah, it's maths.
of the chemical extract from
I do the exact same thing with maths.
Now,
I got 60, 70%.
have been tested and trialed. Firstly, we need to check the toxicity of the drug and whether it's safe for humans. We then need to check whether the drug's effective. In other words, it treats it
Wow, exactly. When? Recently.
So firstly, testing is called preclinical testing. Now, preclinical testing is not carried out on humans, and that's because the drug could be extremely toxic. Instead, preclinical testing is carried out on cells, tissues, or on lab animals. Once these tests have been carried out, the drug then enters clinical testing, in other words, in humans. In the third stage of clinical testing, very low doses of the drug are given to healthy volunteers, and that suggests that the drug is safe in humans. If the drug is found to be safe, then clinical testing continues in order to find the optimum dose.
Exactly.
This use of side effects.
I'm a diva. I'm a diva.
That's the idea of a placebo. So it's a tablet or an injection with a low alcohol and now some patients will get better if they take a placebo. That's because they think they're being treated, so they believe that they're going to get better.
You're going to be timed out until you learn your lesson. You've been a bad boy.
The placebo or control group receives a dummy drug, which looks exactly like a test drug, but it's got no active ingredient. In a double-blind trial, neither the patients nor the doctors know which people are receiving the active drug and which are receiving the placebo. That's to stop bias.
No.
The doctors pay closer attention to people receiving the active drug. Remember, you'll find plenty of questions on testing medicines in my Vision workbook, and you can get that by clicking on the link above. Okay, so hopefully now you should be able to describe how new medicines are discovered and then tested.
You're being rude in my chat. No.
Hi, and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe what's meant by a monoclonal antibody. You should then be able to describe how monoclonal antibodies are produced. Now, we've already looked at the immune system. We saw that white blood cells can produce antibodies. Antibodies are protein molecules which stick to pathogens like this. Now, there are some key ideas about antibodies that you need to understand. Firstly, antibodies are produced by white blood cells called lymphocytes. Secondly, lymphocytes produce antibodies against anything that the body detects as foreign. Scientists call foreign objects like this antigens. Now, scientists
I'll chuck this out my window.
produce antibodies, and that can be really useful. For example, antibodies are used in pregnancy testing kits and in certain cancer treatments. I'm showing you here a lab mouse. If we inject a mouse like this with an antigen, then lymphocytes will produce antibodies against the antigen. We can then collect the lymphocytes from the mouse. Now, the problem is that lymphocytes like this will not divide by mitosis. So in the next stage, we fuse or join our lymphocytes with tumor cells. Tumor cells are very good at dividing by mitosis. The cell we produce is called hybridoma. Hybridoma cells can produce antibodies and divide by mitosis. In the next stage, we select a single hybridoma cell producing the antibody that we want. We now allow this hybridoma cell to divide by mitosis to form a clone of identical hybridoma cells. So the antibodies produced from this clone of hybridoma cells are all identical. We call these monoclonal antibodies because they all come from a single hybridoma clone. A large amount of our monoclonal antibody can then be collected in a tumor cell. So let's look at some of the key facts about monoclonal antibodies. As we've seen, monoclonal antibodies are produced from a single clone of hybridoma cells. That means that monoclonal antibodies are specific to one binding site on one protein antigen. The benefit of this is that monoclonal antibodies can target a specific chemical or specific cells of the body. And that means that monoclonal antibodies have got a large number of uses. And we look at those in the next video. Remember, you'll find plenty of
Trying
questions
to climb through my window.
on my Vision workbook, and you can get that by clicking on the link below. Okay, so hopefully now you should be able to describe what's meant by a monoclonal antibody. You should then be able to describe how monoclonal antibodies are produced.
No, you shouldn't. You would be despicable. You'd be disgusting. Stinky.
Hi, welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe
Good boy, you're studying.
In the last video, we saw that monoclonal antibodies cells. This means that monoclonal antibodies are specific to a single
I'm not going to unmute me. I'm not going to unmute you.
antibodies against.
I know!
So this makes them extremely useful in medicine, and we'll look at some of these uses in this video. Firstly, monoclonal antibodies are used for diagnosis, and a good example is in pregnancy testing. In pregnancy testing, monoclonal antibodies are used to detect a specific hormone. This hormone is produced by the placenta of the developing fetus. Now, pregnancy testing is based on monoclonal antibodies or CHI, and they're easy to use. The woman simply urinates on the test strip and looks for a reaction. The test is also highly accurate if it's used correctly. Monoclonal antibodies are also used extensively in labs. We can use them to measure the levels of hormones in the blood. For example, if a person's tired a lot and lacks energy, then that can be caused by low levels of certain hormones. So a blood sample is taken and sent off for analysis. The test for these hormones uses monoclonal antibodies. We can also use monoclonal antibodies to detect pathogens in the blood, for example, viruses. The advantage of using monoclonal antibodies in these cases is that they're completely specific to what we're looking for.
Abby!
Another use of monoclonal antibodies is to locate or identify specific.
I'm locked in. Look.
In this cell, monoclonal antibodies have been attached to fluorescent dyes.
Free science lessons.
These then stick to specific molecules within the cell and allow us to see their locations. Okay, the final use of monoclonal antibodies is in treating diseases. As we saw in a previous video, cancer cells undergo uncontrolled mitosis.
What do you mean you can't hear me?
Scientists can make antibodies specific to cancer
How do I
cells.
check?
We then attach a radioactive substance or a toxic drug to the antibody. When the antibody is injected into the blood, it attaches to the cancer cells. Now, the radioactive substance or the toxic drug stops the cancer cells from growing and dividing.
That's not how you spell
The
Abby.
advantage here is that the antibody delivers the substance specifically to the cancer cells without harming other cells in the body. Now, there is a problem. In certain drug trials using monoclonal antibodies, they've been found to produce very harmful side effects.
Right.
So at the moment, only a few drugs are used.
You can hear.
Antibodies. However, in the
Plum Sam's not 7.
countries,
He's 14.
remember, you'll find plenty of questions on monoclonal antibodies in the Vision book, and you can get that by clicking on the link above. Okay, so hopefully now you should be able to.
I need to lock in.
Answers of monoclonal antibodies.
This is what
Okay.
university students
Transfer this to do this onto this one.
Maybe that's your sentence. It's like a steady.
Abby, I climbed out my window.
Hi, and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe what's meant by a pathogen. You should then be able to describe how bacteria and viruses cause illness.
So I can empty my bag. Oh my gosh.
How the spread of pathogens can be reduced or prevented.
I've accidentally disabled live chat. How do I redo it?
This video, we're looking at communicable diseases.
Oh no, I've done it.
Spread from person to
I've accidentally disabled live chat.
infectious. Now, these diseases are spread by pathogens, and I'm showing you the definition of a pathogen here. Pathogens are microorganisms that cause infectious disease. It's really important.
Oh no, how do I do it? How do I do it? How do I put on live chat? Live chat.
We also include protists and fungi, and we're going to be looking at those in later videos. So we're going to start by looking at bacteria. I'm showing you a picture of bacteria under the microscope here. These are a type of bacteria which cause food poisoning. Around 300,000 people in the UK get food poisoning from this type of bacteria.
Oh no.
Fortunately, most
I might have to restart the live, guys.
sometimes it
I've disabled chat somehow.